The motivation for this project came from sitting through most of our classes where the professor would take up a lot of time erasing the whiteboard. It would cause them to put a break in the middle of a concept that they were teaching, sometimes lose their train of thought, and also not completely erase the whiteboard. So we came up with the whiteboard eraser mechanism to aid in convenience and speed of erasing the whiteboard.
Our design project focuses on maximizing the amount of available instructional time that a professor has to teach his students in class. Using a scissor jack mechanism and slots to restrain the motion laterally, a user can uniformly and quickly erase an entire whiteboard by simply pulling down this handle.
Our first big constraint was the size of the board. We had to make sure that the eraser mechanism was 4 feet tall so that it could fit on the board, and that it would erase 8 feet wide so it would go all the way to the end of the board and back and erase everything on it. We also had to make sure it avoided these metal studs here and this eraser tray. So we made the mechanism stick out a few inches so that it would be able to wipe the board without hitting either of these things. Our next constraint was that the mechanism needed to be detachable from the whiteboard so that the user could use it could move it from whiteboard to whiteboard or classroom to classroom. We also needed to make it as light as possible so that it wouldn't be impossible or very difficult to lug a very heavy mechanism across campus. And our last constraint was that the mechanism needed to be easy to use, so we added the locks on each side of the links, and we added in a handle so that the user could easily pull down on it, and it was very usable for everybody. Our first criteria was that the whiteboard eraser needed to decrease the time spent erasing the whiteboard for each class. Through data collected through multiple classes, we found that the total time spent erasing per class is on average 278.28 seconds, which is about 7.54% of the class time. But with the whiteboard eraser mechanism, erasing the whiteboard takes less than 15 seconds for each erase, resulting in about 1 minute saved per class time. The next criteria was that there needed to be minimal effort put into erasing the whiteboard so that the mechanism was practical and usable for all users and professors. And our last criteria was that the quality of cleaning needed to be high so that the user didn't need to spend extra time going back and finishing up erasing after our mechanism was already used. Our first design alternative is the crank handle, which you can see in this drawing here in the fully retracted and the fully extended positions. The crank handle would have 2 4-foot links here, and it would be connected to the wall and the eraser. And it would extend when the user pushed down on the handle here, and it would retract when the user pulled back on the handle. The drawbacks of this design are that the handle would need to be connected to the wall permanently, making it immobile, and the links extend below the board in the fully retracted position, limiting the height that the board can be from the ground, depending on the length of the board. Our second design alternative is the windshield wiper design, shown here in the retracted and extended positions. It includes a permanent link or permanent joint right here, and the user would turn the handle in this direction, moving this link in this direction, and the windshield wipers across the board. The drawbacks to this design include the permanent attachment of this joint to the wall, and the windshield wipers don't fully cover the entire board, leaving parts of the board unerased.
So right now I'm cutting out dowels which will connect the bearings within the links.
We're using standard skateboard bearings on each of the joints, in each of the links. And so in order to fit the links with bearings, we had to drill a hole and then insert them. And also, if you look closely, so here we already have a bearing in each of the links. So you notice that this one is sunk in and this one's on the very top. And that's because we want both of the bearings to be as close to each other as possible so that there's as like small of a length of rod for it to break, right? So we'll go ahead and glue this up.
These are the baseboards for the eraser and the mount. Off screen, these blocks were glued on, which will hold and they're also threaded, which will hold the mounts for both of them. For example, this one will be threaded and have a wheel on the end for the eraser. That way it'll slide. This one will also be threaded, but will have a solid block on the end, which will be friction fitted to the top of the board. These blocks are to hold these bars in place. So the top and bottom of these bars. These bars, which have been reinforced with steel, will constrain the links to only move vertically. Where we'll have a handle right here, which will constrain it within the bars. So this block is shorter than this block. This one needs to be made taller in order to make the clearance of these two links.
Alright, so as Noah just said, our other blocks are currently too short, so we're going to cut an amount off of this one, so along this edge, and then we're going to glue it to the bottom so that way they're the correct height.
So in order to get the sliding mechanism to work smoothly, we had to have one of the pins in the slot sliding, and then one of them stationary and pinned. So in order to do that, we glued the dowel to each side of the frame, and then actually nailed in as well. So it's in there really solid. And that just helps give it some rigidity and some stability, because if both of them were to be sliding in the slot, then they would be all over the place. We had to build off of the original frame here, so we just used some blocks, spaced them evenly, and that way, instead of using one solid piece of wood that was going to be really heavy, we were able to cut down a lot on the weight. And then on top of that, we just used a board with some eraser felt material, just glued that on.
So here's a sketch of what the mechanism looks like in 2 dimensions. Here we have the links at fully closed. Whenever it's fully closed, there's approximately 9 inches between the edge of the board and the wiper. And then at full lock, there's about a 5-degree angle to each of the links, because they get in the way of each other a little bit, so they aren't able to go completely full lock.
For the analysis portion of our video, we decided to calculate the input vertical distance that you had to pull the handle, 2.166 feet, to cover the entire span of the board. While the board measures 8 feet from side to side, due to the mounting system seen here in each of the corners, our eraser mechanism can only cover 7.416 feet. So, in conclusion, pulling the handle 1 foot vertically results in the eraser traveling 3.42 feet horizontally. The actual distance that the eraser traveled came from taking the cosine of the length of the links itself. So with 4 foot links and pulling them 2.166 feet downwards, it extended out 3.673 feet. And then, so 2 of these distances would equal like 90% of the board. If we used the links that were 2 feet long instead, you would need 4 of those cosine values, which equates to 8 total links within the entire system instead of just 4.
Our mechanism is specific to exactly these boards in Dillard. So one way that we could improve it is make the marker and the base links and the links in between adjustable so that it can fit on different size boards, and the eraser will be able to erase like in different classrooms. We could also make our mechanism easier to transport. Right now it's pretty bulky and difficult to carry around. That would be fixed with the adjustable links and base and marker size, and we could also create a carrying case like a briefcase that would make it easier to carry between different classrooms and across campus. Right now our mechanism doesn't function completely effectively, and that's because of how far the links are connected to the eraser and the distance between the board and where the force is on the eraser, and it's causing it to twist and stop and not move completely. And one way we would improve this is moving the links closer to the board so that it would slide much more easily.